Okay, a couple concepts of optimization that I think are very important to understand. They're true for really any optimization, but they're I think very important rules, and so one of those is that if I reduce the feasible region, the maximum will be no larger than before. Okay, so the illustration of this, again, this is true for any type of no longer. That's an O. Oh wait, no larger. I can't read my own writing. Sorry about that. Okay, no larger than before. Okay, so what's happening? If I reduce the feasible space, so again, let's just use something pretty simple here and say there's my maximum line and I'm right there. Well, now notice that if I were to reduce my space by maybe adding some new constraint that actually cuts through like that, and so now my new feasible space is maybe just down here, it doesn't include that anymore. Notice that the maximum has to change. It has to come down here. And again, for us, remember that it got bigger as it went out that way, it got smaller as it came in this way, and that's not always true, but for this picture it works very well to go with this. And so you see that our maximum, by adding that new constraint, it reduced the feasible region, and by reducing the feasible region, I ended up with a smaller maximum. Now, it doesn't have to reduce the maximum. That's why I say no larger than before. It can't get any bigger. It may not get smaller because, again, suppose you have this situation. Well, suppose I added a constraint that came through here, but instead of cutting out all this area, it actually cut out the stuff down there, and so my new feasible region is up here still. And if that's the case, well, that maximum won't change at all. Okay, so it's no larger than before if I reduce the feasible region, and I can reduce that feasible region, or I might reduce that feasible region by adding a constraint. Now, a constraint doesn't have to reduce it. Again, if I had added a constraint way out here that said, well, everything above there is fine, well, that wouldn't have done anything to my feasible region, so I wouldn't have changed my feasible region. But if I add a constraint and it changes my feasible region to be smaller, and again, adding and that's my next item here, and let me then just say for minimums, now we've only been doing maximums, but for minimums, the minimum is no smaller. So it's probably bigger, but we don't know that, but the minimum will be no smaller after I reduce the feasible region. And so now adding a constraint can only reduce the feasible region or keep it the same size. Same size. Okay, and so if I add a constraint to my optimization problem, I would expect my optimization, whatever I'm either maximizing or minimizing, to possibly not be as good if I have to add another constraint. And again, that's just the idea of we're reducing the feasible region. Now, I don't have to reduce the feasible region. So let's say I have a feasible region that works this way. So here's x, here's y. Here's x plus y is less than or equal to 1. And so we're down here. Here's x is greater than or equal to 0. That goes up this way. Y is greater than or equal to 0. That goes this way. And so we're in this area. Now notice that if I had, we'll just work with the y. If I have the constraint, a new constraint that says, oh, by the way, y has to be less than or equal to 2, well, actually that doesn't do anything because x plus y equals 1, it goes through here at 1. And that one goes through at 1, and y equals 1. And so if we have to have y less than or equal to 2, well, that says we have to be down here. Y has to be less than or equal to 2. Well, we've got to be well below a line that's way up here in my writing somewhere. Well, so that didn't do a darn thing. That didn't change my feasible region. It's still this little triangle here. Now, but on the other hand, if I said, oh, y has to be less than or equal to a half, oh, well, a half cuts through right here, and if y has to be less than or equal to that, now all of a sudden I have this trapezoid for my feasible region. So you see, adding that constraint made it smaller. But adding a constraint will never make it bigger. So it may not change it. Okay, it may make it smaller, but it never makes it bigger. And so those are the two big concepts when you're optimizing a problem, is that if you have to reduce what's feasible to do, you can't do any better than you could have done before. That's what this is saying. And then, well, if I have to add a new constraint or a new constriction or restriction, then I probably, I don't know that for a fact, but again, my feasible region, it's either going to stay the same or get smaller. So you put those two things together, and if I'm looking at a problem, every time I add a new constraint or a new restriction to my problem, I expect that whatever I hope to either maximize or minimize will not be as good as it was before. Okay, that's the bottom line, and so that's what we wanted to try to talk about for this video.